Similar triangles is the topic of the new chapter which we're going to deal in the session. The word similar is something which is quite new for the branch of mathematics here in this part of similar triangles. So what is similarity? How do you define that mathematically, or how do you understand similarity to the most simplest meaning of its understanding? So what is similarity? A similarity is something which we see in similar because the word similar means they are same or representing the same. So if I take the general meaning of similarity, similarity is representing as same. In general sense, we call similarity as representing as same, but in the other form of understanding, we say that similarity is where two different objects look similar but they are not equal in size. Say for example, I take a small cricket ball, and then I take a huge football. Then I say that these two objects, the one which is a cricket ball and the one which is a football, are similar. The symbol for similarity is this. So we say that the two objects, cricket ball and the football, are similar. So what makes me define the two objects to be similar? Why not a cuboid? Or when I take a dice and say, why not a cricket ball is not similar to a dice which we use in the games? Etc. Why is that a cricket ball is similar to a football, and why is it that either of these two objects is not similar to a dice which is thrown in the game of Sudo? The reason is these two objects are said to represent similar, but I don't have any similarity between these two objects, because when I take the first two objects, they are round in shape. They are said to be, though not in equal size, but they are both round in shape. Therefore, my round in shape is what is understood through the similarity of the two objects. This is not round in shape, so I say these two are not similar, or these two are also not similar, but these two are the similar objects. So similarity in general sense is understood as the objects which represent as same. Say for example, I take a very small triangle, minute, and I say a very large triangle, then these two triangles are said to be similar, but there are some mathematical properties which are included in identifying whether these two triangles are similar. So when I take the concept of triangles, similarity is identified through their angles, the corresponding angles which need to be equal, and the sides which must be in same ratio. So we are going to discuss more further in future sessions on how these two triangles are similar based on their angles and the corresponding sides. So different objects have different similarity which we're going to identify mathematically through the angles and the corresponding sides. But initially, to understand similarity, similarity is the representation of the objects to be same, but not equal in size, but can be with different sizes, but they can be similar. So before we go in depth into understanding of similar triangles or similarity of two objects, I want to come out with a real life example on why similarity is important in mathematics. What is the significance of similarity is more important to understand before we understand the similarity in its more mathematical sense. So what is its significance? Now let's see the significance of similarity to understand similarity in its more definitive manner. So let's see the significance where I connect this with real life example. Once, say for example, Snigdha has gone to an open ground and she found one of the tree there on the ground, a very tall tree. So Snigdha was just on the ground and she stood out here. She just stood here and she was trying to watch. She was just standing here on the ground and she was wondering a very tall tree in the open ground, which was here. So she was wondering what could be the height of the tree. She wanted to measure without actually measuring with the tape, because a very tall tree, it's very difficult to measure with the tape, because climbing that and going to such a tall height would not be an easy task. So she was wondering on how she can find the height of the tree using mathematics. Then immediately she has seen one of uncle coming out there who was basically very good in maths, and then she was asking him about the same question which has puzzled her, on how to find the height of the tree without actually measuring this with a tape. Then in this case, she was just puzzled, and her uncle looked at her for a while and then asked her to get a small mirror. Then she brought the mirror and he asked her to put the mirror somewhere on the ground here. So she put the mirror here on the ground, and then, so this is entirely the ground, and she placed the mirror on the ground here. And she asked her to start looking into the mirror until this top of the tree, which is until this top of the tree is visible here. So she started adjusting herself in different positions to see where, until she reaches to that place on the ground where she can see this top of the tree on into the mirror. So until she could see this point of the tree into the mirror, she halted there. Now once she got the position where the top of the tree was identified, then she started looking at that top from here. Now in this case, I identify two triangles. One is the right angle triangle ABC, where AB is the height of the girl Snigdha and C is the mirror, where exactly the position of the mirror is where both of them can see the top of the tree, where she can see the top of the tree which is on the other side of the mirror.